Hey everyone, welcome to my final project for Bio 162, where today I'm going to be going over the concept of homeostasis and different labs that we did in this class that really helped drive away or drive home the point of what homeostasis really is. So the first thing that we need to really just go over very briefly is what is homeostasis? Now, the way that I like to think of homeostasis is our body's internal subconscious clock that is basically like a weight scale that doesn't allow our body to have too much of something. It will basically counteract if there is an outside stimulus that is producing or making a change too much of something, our body will subconsciously reverse it or, balance it out. And something else that's really big about what homeostasis is, and the real driving point, is it regulates optimal surviving conditions for the human body. And this is through things such as temperature, stability, subconscious organ function, and negative feedback loops, which is how it really does, or it goes, that's really how the body goes about homeostasis a lot, is negative feedback loops, which we'll get into that a little bit more as we go on with this presentation. So the first lab that one of the very first labs we did after histology was we learned about the integumentary system in Bio 162. And I guess the real question here is, how does it exactly maintain homeostasis? The integumentary system is very debatably the most complex organ in the human body because it also happens to be the largest, but it also is very debatably the most important when it comes to contributing to homeostasis because it deals with our outside environment. It is one of the only organs in the body that is exposed to the external environment. So through sweat glands, sensory receptors, and our hair follicles, these are just key factors and, key importances that really help drive home homeostasis. And we'll go over this a little bit more in our narrated drawing that I'm going to be just sharing, and we'll go over these examples a little bit more. But the integumentary system is very important when it comes to homeostasis. And secondly, the other lab that I'll be demonstrating today that really just drove home the theme of homeostasis was the nervous system. We also we learned about the nervous system, but more specifically the autonomic nervous system. And the autonomic nervous system is very important in contributing to homeostasis because it most importantly will help maintain subconscious organ function, and as well as stability and through negative feedback loops as well. Because if we recall back, homeostasis is what regulates our optimal surviving conditions for the human body. And our nervous system is what really does all of this for us, and it helps contribute to helping our body survive. So anyway, I'm going to go ahead and pull out the pen now, and we'll go into this a little bit more. So the first thing that we really just touched on in the integumentary system that contributes to homeostasis, and is a perfect example, is our eccrine sweat glands that are right here, and they can be seen right here in white. And well, what do? So our sweat glands, when our body gets too hot, well, why do we sweat? Our body gets too hot, and it's just a natural reaction for our body to sweat. But why does this happen really? Well, it happens because it helps protect our body from overheating. When our bodies begin to overheat, we're in danger of potentially passing or collapsing, passing out or collapsing. So what our body does is it subconsciously begins to produce or secrete a liquid, and will go through these ducts and will excrete over to the surface layer of the epidermis, which helps cool the body from overheating. And this is a perfect example of what homeostasis is, because through negative feedback loops, the body is counteracting, heat. It's helping cool down the body. And the same exact thing can be said about hair follicles. Well, how do they contribute to homeostasis? Well, our hair follicles, which can be seen right here, the largest structure here seen in the integumentary system of the dermis, these hair follicles grow little hairs right here. And these hairs, when our body gets too cold, will help protect our skin from, getting too cold. Now, again, our body can only do so much to help keep us protected from, exposure to frigid temperatures, but our hair that we have right here will help protect us from the freezing cold. And this is also why we get goosebumps too. And finally, our sensory receptors, which are seen right here, they also help drive home the point of homeostasis because what our sensory receptors do is they will, they'll detect and any stimuluses that come from the external environment, and they will detect it and tell the brain how to react accordingly. So, for example, let's say you touch or you put your hand on a really hot stove, on a really hot coil. You're obviously going to pull away your hand, but why is that? Well, the heat will travel through the epidermis of the skin and reach the sensory receptors almost instantaneously. And these sensory receptors are immediately going to travel through all the way through into the hypodermis and beyond. And they're going to travel through our nervous system, which we'll touch on very briefly. And they're going to tell you it's going to go to your brain, and your brain is immediately going to send a signal right back telling you, pull your hand away. Like that's a really hot stove. So this is important, and it really contributes to homeostasis because it's basically, counteracting or making a reversal of one specific action because there was too much of a stimulus at one time. Our body began to, we began to feel a pain sensation. So our body is automatically reacting to help counteract that. And that's exactly what homeostasis really is. So finally, we're going to just touch on the nervous system really quick. And we're going to link these together. We're going to link this together with the integumentary system. So back to the concept of the sensory receptors. So we got little sensory receptors all over our skin here, right? We put our hand on a really hot stove. These sensory receptors are going to travel through our little neurons, and they're going to send a signal all the way to the brain. And our brain is immediately going to send a signal back to the hand and to the neurons here, and they're going to say, pull your hand away, subconsciously. You could tell yourself not to, but you're still going to end up pulling your hand away because, well, that's just natural human instinct. And this, again, contributes to homeostasis because it's counteracting a powerful stimulus that your body cannot handle. So how else does the nervous system help contribute to homeostasis? Well, again, if we recall, homeostasis helps maintain optimal surviving conditions for the body. And part of this is organ function. When we, live day-to-day life, we don't tell our eyes to blink. We don't tell our heart to beat so that it can pump blood. We don't tell our stomach to digest a meal that we just ate to get the proper nutrients. We don't tell our lungs to breathe because if we had to do all those things, we would die in our sleep and it would be too much for us to remember. So that's why our autonomic nervous system does all of these things. So our autonomic nervous system will subconsciously send signals to our heart, will send signals to our lungs, will send signals to our stomach, all these different places in the body, other sensory receptors, etc. So forth, when we need to use the bathroom, our body will will tell it to do certain things that it needs to do to help maintain that optimal surviving. And that's really what exactly homeostasis is and how our nervous system really contributes to this concept. So anyway, through these, I feel like these labs were the best at contributing to what homeostasis really was because it was something that we learned a lot about in Bio 162. But at the same time, I definitely feel like this was also a very important concept that we learned about through Bio 162. So that's why I chose these labs to help represent this, and I felt like they were the best two that really helped portray, the importance of homeostasis and what it really is. So hopefully this made a lot of sense. But anyway, I hope you guys enjoyed this presentation, and if there's any questions, just feel free to leave a comment, and I hope all of you have a great day. Thank you.